Hi, hope you're all fine and safe. This is our last quarter. We're going to talk about nuclear chemistry. Nuclear comes from the word nucleus, so we're going to talk about everything concerns the nucleus. Nucleons, they are the constituents of the nucleus. And what are the constituents of the nucleus? Protons, they are positively charged particles found inside the nucleus. Neutrons, and they are neutral particles, and neutral means that the positive and the negative charge particles are equal. Revolving around the nucleus with a very high speed, there are negatively charged particles called electrons. Okay, first of all, when does a nuclear reaction takes place? The nuclear reaction takes place in atoms having high number of protons, like for example the uranium element. Uranium element have about 92 protons. So 92 protons having positive charge inside this small nucleus. So high repulsion happens inside this nucleus, makes the atom completely unstable, makes the atom very, very active. So in this case, the nucleus needs to get out this energy. So it gets out this energy in the form of radiation. Radiation, each radiation consists of particles. We're going to talk in the next lesson about the kinds of radiation, but now you just have to know that each radiation consists of particles. So when the nucleus gets out this energy, it gets out the particles, which makes it unstable until this atom becomes stable. So these atoms undergo this process. We say that these atoms are called radioactive elements. So number one, the radioactive elements are elements having high number of protons. The second type of radioactive elements are radioisotopes, or we call them unstable isotopes. We all know isotopes, that they are atoms of the same element having the same atomic number or same number of protons, but they differ in mass number or number of neutrons. So as you see here, that hydrogen 1,1 is found in the periodic table. Why this one is found in the periodic table? Because it's the most common hydrogen in nature. Hydrogen 1,2 and hydrogen 1,3 are also present in nature, but they're present in small quantities. So as you see here, that hydrogen 1,2 has one more neutron than the normal hydrogen, and here it has two more neutrons than the normal hydrogen. So the atom needs to get out or to get rid of the extra particle here and the two extra particles in hydrogen 1,3, which makes it unstable. So it gets out these particles in the form of radiation. We call these elements that gets out the extra energy in the form of radiation, we call them radioactive elements. So radioactive elements are two kinds. Number one, atoms with high number of protons that undergo repulsive force between each other. So they need to get out the extra energy. So they get out this energy in the form of radiation. Or number two, radioisotopes, which have extra nutrients. So they need to get out these particles, to remove these particles. So they begin to get out these particles in the form of radiations. Okay, so we're going to talk now about a very important definition called radioactivity, or we call it radioactive decay. What is radioactivity or radioactive decay? Radioactivity is a spontaneous emission of rays or particles from certain elements such as uranium, which is a radioactive element. First of all, why we say it is spontaneous? Because these atoms, I mean the atoms with high number of protons or the radioisotopes, they get out the extra energy spontaneously. They do not need any influence. I mean, they don't need a catalyst, for example, to start the reaction. They don't need, like the chemical reaction, for example, the metal needs a non-metal so that the metal lose electron, the non-metal gain electron. No, this reaction in case of a nuclear reaction happens spontaneously without any emission. I mean, if I have an uranium element and it has these 92 protons, so automatically it gets out this energy in the form of radiation without any factor that affects it, like temperature, catalyst, pressure, or so on. That's why we say it is a spontaneous emission. And this is an important difference between the nuclear reaction and the chemical reaction. The second definition is nuclear radiation. What is the nuclear radiation? They are the rays and the particles emitted from a radioactive source. The rays, we call it nuclear radiation. Radioactive source, I mean it's the radioactive elements like uranium or your radioisotopes. Radioisotope, we just mentioned its definition before. But an important thing I need you to know that in case of radioisotopes or any radioactive element, that it will undergo spontaneous decay until what? Until the unstable element change into a stable element. So this may happen in one step, in two steps. It may get out one kind of radiation, two kinds of radiation, three kinds of radiation, in one step, two steps, three steps, but at the end, it must change into a stable element. Okay? The process continues until unstable isotopes of one element are changed or transformed into stable isotopes of different elements. These stable isotopes are not reactive. So at the end, I have a stable element. The stable element is non-reactive anymore. To sum up, we can now differentiate between nuclear reaction and chemical reaction. In both chemical and nuclear reaction, atoms becomes more stable. Yani at the end, I have a stable element. Okay, let us now compare between chemical reaction and nuclear reaction. In a chemical reaction, atoms tend to attain a more stable electronic configuration by transferring or sharing electrons. We all know, of course, the chemical reaction. Okay, we took it before, that in any chemical reaction, I have a metal, for example, that its outermost level have 1, 2, 3 valence electrons. And I have a non-metal. It has, for example, 5, 6, 7 electrons in its outermost energy level. Metals tend to lose electrons. Non-metals tend to gain electrons. But in the end, this reaction needs something to start it, to stimulate it. The metal begins to lose electron when it finds the non-metal. Sometimes this reaction needs a factor, for example, like temperature, to increase the temperature. Sometimes other reaction needs a catalyst. Sometimes other reaction needs, for example, a catalyst. Till what? Till the atom becomes stable. And everything here happens with the electrons inside the chemical reaction. In a chemical reaction, we say it is non-spontaneous because I have to start the reaction. The reaction will never start alone. I must start it. I must have certain factors, important factors to start the reaction. I must have a metal and a non-metal to start the reaction. Okay, but in case of a nuclear reaction, the reaction, when I have an unstable isotope, like we said in the beginning of the lesson, this reaction happens spontaneously. The atom begins to get out the extra energy spontaneously until what? Until it changes to a stable element. Okay, while doing this process, a great amount of energy is released. The nuclear reaction here, it's not affected by anything, by temperature, pressure, or catalyst. I cannot stop this reaction. I cannot start this reaction. I cannot accelerate this reaction. This reaction will happen spontaneously until this unstable isotopes, it becomes a more stable element. This is the difference between nuclear reaction and chemical reaction. Okay, the last thing here in this lesson, we're going to talk about nuclear force. What's nuclear force? I have two kinds of forces. I have an attractive force and I have repulsive force. Inside the nucleus, what generates these forces? First of all, the repulsive force, when the number of protons are great, so the repulsive force is great. That's why when the repulsive force is higher than the attraction force found in the nucleus, here I have an unstable element. But when the attractive force is greater than the repulsive force, here I have a stable element. What is the attractive force? Attractive force happens between the protons and the neutrons. How the neutrons? Although the neutrons is neutral, but it has positive and negative charge. So when the attraction force happens between the protons and the negative part inside the neutron, this creates an attractive force inside the nucleus. So when the attractive force is greater than the repulsive force, I have a stable element. When the opposite happens, that the attractive force is less than the repulsive force, in this case, I have an unstable element. Okay, thank you.